We are going to take a look at naming acids and bases. So for naming acids, if you see a binary acid, and a binary acid has a hydrogen and then it has some other element, okay, it's going to typically be a nonmetal element there. And what you're going to do is you're going to say hydro in front of that, and then you're going to give the name of the element, and it will get an ic ending. So if I had HCl, I'd have hydro. Instead of chloride, it would be hydrochloric acid. Oxyacids have more than two elements. So they'll have the hydrogen, and then they'll have at least two other elements in there. Typically, one of those other ones will be oxygen, therefore called an oxyacid. So you don't put a hydro in front when it's an oxyacid or when you have more than two elements, but you give the name of the ion, and if the ion ends in an 8, you're going to change that to an ic ending. If it ends in an ite, you're going to change that to an us ending, OUS ending, right here. I think we'll see these examples in the following set. So HCl, it's binary, there's only two things, so it's going to have the hydro in front, and then the chloride gets changed to chloric, hydrochloric, and then we write acid at the end. If I have H3 end, it's still binary, even though I have three hydrogens and one nitrogen. There's only two different types of elements. And notice nitride has a -3 charge, hydrogen plus 1, so I put 3 on there, so it balances it and makes it neutral. Okay, so then it becomes hydronitride becomes hydronitric acid right there, but you'd have to balance it for charge, trying to make it neutral. Okay, the other one is HNO3. Notice it's an oxyacid, so we're not going to include the hydro in front. I look up the charge of NO3 on my common ion chart, and I see that it is -1. So NO3 has a -1, H has a +1, so it's balanced as is. And I don't write the hydro, I just put nitric acid. The nitrate ion ends in an 8, so it changes to ic, and it becomes nitric acid. And then if I look at HNO2, that comes from the nitrite ion way up here. And notice it's still an oxyacid, no hydro, but it ends in an ite, so it becomes nitrous acid. If you have more oxygens, you get the ic, less oxygens, you get the us. Just like more oxygens, you get the 8, less you get the ite. That's the trend you'll see on the chart. So those are the rules for naming acids. On your common ion chart, you have this. You have these rules here. They're also listed on your naming rules on the back of your common ion chart. So you have a one-stop shop for finding those things. What about naming bases? Strong bases are hydroxides of alkali metals or alkali earth metals, family 1 or family 2. So we've really been naming these. NaOH would be sodium hydroxide. BaOH2 would be barium hydroxide. Notice this is a +2 for barium, -1 for hydroxide. There's two of them to balance it out. But we do not say dihydroxide because it's still ionic. Only with the covalent ones do we use the dis and tris, etc. So this is barium hydroxide. All right, let's look at a couple examples. And HF is what? It is binary, so I'm going to say hydro, fluoride becomes ic, hydrofluoric acid. Another one would be, we have C2O4. I look on my common ion chart, I find that that is the oxalate ion. I think, if I can find it, way up here. It's the oxalate ion with a -2 charge. So because this has a -2 charge, I need two hydrogens to balance it, and it's H2C2O4. But I don't put a hydro in front. It's just oxalate becomes oxalic acid. The 8 becomes an ic. And finally, this one right here looks like an OH compound, so that's going to be hydroxide. That's going to be a base. It is sodium hydroxide. Going over to this column where you're given a name, if I see the hydro, I know there's just two elements. The hydrogen is one of them. The bromine is another one. Plus one, minus one. It is HBr. This looks like a hydroxide. That's a base. Calcium is +2. Hydroxide is -1. So it's CCA in parentheses OH2. You do need the parentheses. You have two O's and two H's. And the last one would be dichromic acid. Oh, I thought when we did ionic stuff, we don't use dis and tris. Well, that's true, but this ion is called the dichromate ion right here, Cr2O7 -2. So that whole thing has a -2. I balance it with two H pluses, and dichromic, it's an 8, so it gets to be ic, dichromic acid, and it's H 2 times +1, so it's got a 2 there, and then Cr2O7 is the -2 ion, the dichromate ion. Okay, practice these and then check them and just make sure you have your acid and base naming correct.